a bell curve, right? Have you heard of a bell curve? That's when things are normally distributed when it's a bell curve. So if I looked at your grades and I could crunch stats with your grades, I would be looking for a normal bell curve to kind of peak probably somewhere around 85, I would say, would be nice. It's probably truthfully more like 80, which is mastery, so whatever. But a bell curve is a normal distribution. This on the bottom is the number of standard deviations, okay? So if you are 0 standard deviations from the average, then you are right at the average. Yes? So we'll say, let's let the average be some X number, 80%, I don't know. This is a half of a standard deviation above. So sometimes this down here is labeled by standard deviations, like this one is here. This is indicative of the number of standard deviations we are above, and on the bottom, and the number of standard deviations we are below. But sometimes they'll label it with the actual average. So if that was the case and this was labeled like 80%, like the average test score, this number would be whatever that average is plus a half of a standard deviation. And this would be the average plus 1 standard deviation, and that's how they would label the numbers on the bottom. Okay? But essentially, I don't really so much care about half standard deviations. What I really want to focus on first is 1 standard deviation away. If you are 1 standard deviation away from your average, you're within that range. In theory, we talked about yesterday that would be what percentage of the entire population? 68%. So in theory, approximately 68%. Truly, if we have like an infinite sized sample, those add up to what? 15 plus 19.1 plus another 19.1 plus another 15. 68.2 is the actual exact one. But our curriculum says we can use 68. Yes? And if we go out 2 standard deviations, 2 above, 2 below, so on top of that 68.2%, we're going to add another 4.4%, 9.2%, 9.2%, and 4.4%. Now between these further two, I'll do it like this. That's approximately 95%. And this graph just further breaks it down into more exact percentages, okay? And so if someone ever asked you, well, what are the chances you're between 1 standard deviation and 2 standard deviations above? Well, 1 and 2 standard deviations above is from here to here, so you're talking about this 13.6%. 13.6% of people will be between 1 above and 2 above. And so depending on what little window they ask you for, you're just going to add up those percentages appropriately. Okie doke? You don't have to memorize this table. If they wanted you to use it, they'll give it to you. Okay? But it just breaks it down more perfectly. Okay? So if we go to your notes on normal distribution, example 1. Find the percentage of the population for a population that is normally distributed. Okay? Find the percentage of the population that lies within 1 standard deviation of the mean. We did that and we're just going to assume that they're giving us this as like a side thing. We said it was 68.2%. I never added the within 2 standard deviations exactly, did I? So it's that 68.2 plus 4.4 plus 9.2 on the bottom side, plus another 4.4 and another 9.2 on the top side. 95.4%. Okay? So here's kind of how they'll switch it up. More than 3 standard deviations away from the mean. More than 3. And it doesn't say above or below. It just says more than 3. So I'm assuming that means on either end, yes? So more than 3 on the top end is 0.1%. More than 3 on the bottom end is another 0.1%. So that would be what total? 0.2%. So not even 1%. And then D says between 1 and 2 standard deviations above. So that would be kind of this little section that I did coincidentally already talk about. Between 1 and 2 above would be 9.2 plus 4.4, which is 13.6%. So just being able to use that normal curve and understand what those percentages are telling us. Okay? Exercise 2, at Arlington High School, 424 juniors. That's the population that just took an SAT. On the math portion, the average was 540 with a standard deviation of 80. Okay? So here is where I would draw my curve. And 540 would be my center. So I would label this not with 0 to mean 0 standard deviations from the mean. I would label it with the average of 540. And then 1 standard deviation above would equate to what score? 620. That's 80 above. And if I went another 80 above, that would bring me 2 standard deviations above. Agreed? So in parentheses, you can put 0 for 0 standard deviations. You can put 1 for 1 standard deviation and 2 for 2 standard deviations, if you want. I just prefer really to label these based on the actual score. And if I want to go 1 below, I'm going to subtract off 80, which would be 460. That's negative 1 standard deviation. Subtract off 80 more. 380 would be negative 2 standard deviations. This just helps me wrap my head around the distribution. Okay? So the questions are, what percent fell between 500, which is here. How many standard deviations away is that? A half below, so negative 1/2 standard deviation below. And 660 is here somewhere. How many above is that? 1.5. Yep. And 1.5 standard deviations above. So you would just go to your chart. A half standard deviation below is from here to 1.5 above is here. And add all those percentages in between. So 19.1 plus 19.1 plus 15 plus 9.2. Jason, hit me with it when you get it. (62.4%). So the way that was phrased, it said what percent? Wonderful. B is phrased with the same window between 500 and 660, but this is saying 1% in part A, and this is saying how many in part B. How many kids is that? 62.4% of 424 kids is how many kids? So we essentially need to take our percentage and apply it to the 424 juniors, and that'll give us how many kids? How do you calculate 62.4 of 424? Multiply, and you have to change your percent to a decimal. So 0.624 of 424. How to calculate percentages, round your answer to the nearest whole number, 265. How to calculate percentages should be like a middle school topic, but I know that my husband still struggles with it, so I'm sure that some of you do too. Can't tell you how many times he's like, wait, can you quickly tell me, how do I calculate this percent again? If percents do a funny thing to us all, right? How many people feel like they're terrible at percentages? Oh, look at Haley own that. Anyway, so pay attention to what they're asking. Are they asking for the percentage, or are they asking you how many, which means you still have to find the percentage, but then you actually have to apply it. Capiche? Any questions? All right. If Evan scored a 740, what percent of the students who took the exam did better than her? So if she scored a 740, where is she on the standard deviation chart? Exactly, though, where is she? How many standard deviations above is she? 2.5, right? Because each standard deviation is worth 80, so if we wanted to go by the halves, you would go by 40. So she's exactly 2.5. So she's exactly right here. The question is, what percentage of kids did better than her? So add these up. 0.6%, right? 0.5 plus 0.1. 0.6%. And then again in D, they say, well, how many is this then? Of the 424 juniors, we want 0.6% of 424 to figure out how many that is. Now, this is tricky because the percentage is already in a decimal. We have to further make it the decimal version, which is 0.006 times 424. We don't want to do 0.06 because that'll be 6%. We don't want to do 0.6 because that'll be 60%. 0.006, it should be a very few kids. 2.5, we'll say 3. Approximately 3 kids did better than her. Questions? We good? Making sense. Okay. Okay, carry on. New question. Heights of 16-year-old teenage boys are normally distributed with a mean of 66 and a standard deviation of 3. You know what? This reminds me of myself being a broken record like I was with the trig chapter. In the trig chapter, I was always like, draw it, figure out what quadrant it's in, turn it into a right triangle, and use SOHCAHTOA. With this chapter, it's always going to be draw the normal curve and label it, just to give yourself time to wrap your head around what's going on. So the mean is 66, and the standard deviation is 3. So I'm going to label a 69 and a 72 to go 2 standard deviations above, and a 63 and a 60 to go 2 standard deviations below. If Jabari is 72 inches tall, he's right there at that second standard deviation. Which of the following is closest to his height's percentile rank? Okay. We got to talk about this because this is something that I'd like to think that you know, but I find that the reality is you don't know it. You've been taking standardized tests your whole life, yes? Do you remember finding out that you were in like the 72nd percentile? Do you remember that? Or you were in the 94th percentile, hopefully? Correct. Percentiles are better than the score because they give you a feel for how you are performing relative to everybody else, which is really more important than your score itself. So what does that mean? If you scored in the 72nd percentile, does that mean you got a 72? Absolutely not. What does it mean, Lucas? Right. So that means if you're in the 72nd percentile, that means you did better than 72% of the people. That's pretty good. Which means 28% of the people did better than you. Yes? Does that make sense? Okay? So if you're asked and you see that word percentile, it's what percentage of the people was this kid taller than? It's all of these percentages added up. Yes? He is above all of these people. So he was exactly 2 standard deviations above. He's right here. He is taller than all of these people. So we add them all up. Yes? So, oh boy. 0.1 plus 0.5 plus 1.7 plus 4.4 plus 9.2, yada yada, 15, 19.1, again 19.1, 15, 9.2, and 4.4. 97.7%. These all add up to 97.7% of the people. So he is in the 97.7 percentile, which is the closest to the 98th. Anytime you see percentile, it's all the percentages underneath added together. Capiche? Caposh. Right, Lucas? Look at my secretary getting to work. You go for it. Where were they? All right, next one. The amount of soda in a standard can is normally distributed with a mean of 12. Does every can of soda have 12 ounces in it? Probably not, right? Don't you think some of them have 11.9 or like 12.1? Or you think they're all exact? You think those machines in their factories are like error-free? They're not. Average of 12, but the standard deviation is very small. So it's a very small deviation, but one standard deviation away would put you at 12.6. One standard deviation away on the bottom side would put you at 11.4, which means 68% of them are between 11.4 and 12.6, and truthfully, who's going to know, right? You have no clue. Two standard deviations would put you at 13.2. Another standard deviation below would put you at 10.8. If 250 soda cans were pulled by a company, how many would you expect? So they're saying how many. So we're going to find the percentage, but then we have to convert it. And we have to figure out that percentage of 250 to figure out how many of these soda cans. Don't be looking at your tests right now. Pay attention to this one, because this is where I do lose people when all of a sudden it asks how many. We still need the percentages of less than 11.1. How many standard deviations below is 11.1? 1.5 below. So less than that. So here's 1.5 below. These percentages all add up to 6.7%. So it would be 6.7% of the 250 are expected to have less than 11.1. So that's 0.067 out of 250. I'm actually surprised they don't have 6.7 as an option to throw people off. People who are just going to take the percentage and go on with their life. We want 0.067 times 250, which is 16.75 cans. That's approximately 17 cans. Are we good? We have our head wrapped around it? It's just more of the same for the rest of it, except for, of course, there's always a but with me. Really quickly, and this I think you know. Again, I don't know how much it comes up, but we've been talking today about normal distributions, which are normal bell curves. In real life, there's not a lot of perfect bell curves. This one tails off to the left. Do you see how the tail is to the left and it's kind of more peaked over here? Whichever way it tails off, we say it's skewed left. This one tails off longer on the right, so that one would be called skewed right. Okay? When it's perfectly symmetrical and normal, your mean, median, and mode are almost all the same number. Versus when it's a skewed distribution, like the income levels we talked about yesterday, the mean, median, and mode are not all necessarily at the center of the data because there really is no center. And what is this one? Skewed left or skewed right? Skewed left because it's where the tail is, yes? Hold on, your homework's coming. Listen, we need to work on the snaking of our homework. It's going to go down and back and down and back, and she's going to end up with the extras and she's going to leave them on my desk, yes? Okay, the test is out of 30. Scaled it was out of 30, but I gave you your bonus points back first. So if you got -6 and then you got +2 back, you really only lost 4 out of 30, so calculated 26 out of 30. Does that make sense? Anybody who thinks that they want to take the retest tomorrow? Okay, that's wonderful. Do your corrections tonight. It would be pointless for you to just come in and take it again just for fun. Because if you do worse, you're getting your worst grade. So put the time in, do your corrections tonight. Capiche? Capash, says Lucas Cladoba.
I'm going to do it first period since I can't stay after school.
Yes, you will. But you're going to want to make sure you get in somehow and ask me questions. Chloe, did you have something? Oh, I thought you were standing right there. Okay. No Natalie, no Vince?